I wanted to take a quick lesson on how to determine or read what the end behavior would be for a graph without actually graphing it. So end behavior of graphs without graphing. So just looking at the polynomial. So in this case, what I am talking about is if I am given the polynomial x squared plus 3x minus 6, and then another polynomial that's going to be negative x squared plus 3x minus 6, we can look at the degree of my polynomial and also the sign of my leading coefficient, and I can tell you how my graph is going to behave. So, if, bottom line, this is how it works. If I have a graph that has an even degree and has a positive leading coefficient, so this is even degree with positive leading coefficient, then it's going to be up and up, okay? Meaning that as x approaches negative infinity, y is going to approach positive infinity. And as x approaches positive infinity, y is going to approach negative infinity. So that graph is going to be different only in the way that the arrows point on either end. Now it's even, both of them point up. Even and positive leading coefficient. Now if I have this over here where it's negative x squared plus 3x minus 6, then you can see that I have, it's going to end up looking like this. Whereas they're both pointing down, but they're both pointing in the same direction. So this is when I have an even degree and a negative leading coefficient. And this is as x, so I'm gonna put a little box around this so you can see which one belongs to which. So as x approaches negative infinity, y is going to also approach negative infinity. And over here, as x approaches positive infinity, y is going to approach negative infinity. So that's my end behavior for those graphs. So no matter what graph it is, if it is an even leading coefficient, so 2, 4, 6, 8, 10, even degree, and the leading coefficient is positive, both are up. If it's an even degree, leading coefficient is negative, they're both going to end up being down. Okay? Now, the other situation is where you have an odd degree. And this, in this case, is like x to the third plus 8x minus 4. Okay? And in this case, we are going to start low and end high. It's odd. It doesn't end up in the same place. They're not the same. It's odd. It's different. It means that one starts one place and the other. But this is for a positive coefficient, positive leading coefficient, and an odd degree. So in this case, I'm going to end up with, as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, then y approaches positive infinity. And I can say y or f of x, either one is fine. So this is for odd and the leading coefficient is positive. Now, same thing's going to happen that happened up here. If I put a negative in front of my leading coefficient, so negative x cubed plus 8x minus 4. If it's negative leading coefficient, but it's still odd, so they're going to be different. But in this case, instead of starting low, I'm going to start high. So as x approaches negative infinity, y is going to approach positive infinity. And as x approaches positive infinity, y is going to approach negative infinity. So that kind of explains the end behavior a bit. And you don't even have to graph it or have a graphing calculator or anything like that. You can just look at the leading coefficient and the degree of the polynomial. Now, on that note of graphing, we also learned some other information. And this information was kind of covered yesterday when you worked on graphing the polynomials. So, or looking at the graphs of the polynomials. So let's look at the first one that we did. And the first one looks like y is equal to x times x minus 1 times x plus 2. So, just seeing this polynomial, I can solve for my roots. I know I have a root as x is equal to 0, I have a root at x is equal to 1, and I have a root at x is equal to negative 2. So graphing it without using a graphing calculator, without doing anything, I can see automatically that I'm going to have a point that's going to go through at 0, a point that's going to go through at 1, and also a point that it's going to go through at negative 2. Now in this case, my leading coefficient is going to be odd and positive. So if you look at my notes that I just gave you, you can see that it's going to look something like this. And notice it's just going through those roots. It's just going through that. So that's how the graph would look without knowing anything else or using my calculator. Now, another situation is, let's look at something like number 6 read y is equal to x times x minus 3 squared. And in this situation, I can see I have a root of 0, and then I have x minus 3 is equal to 0, I have another x minus 3 is equal to 0, and I have another x minus 3 is equal to 0. So x is equal to 3 times. And in this case, this is where I'm going to have, it's going to go through at 0, 0. And when I get to the point of 3, 0, it's going to actually squiggle. Now, my leading coefficient is going to be even, so they're both going to end up in the same way. They're positive. So it's going to look something, oh, I don't even know. It's going to look something like that, right there. And the squiggle there tells me that I have that root 3 times, or it has a multiplicity of 3. So, multiplicity, 3 has a multiplicity of 3. So, that kind of helps that situation. Now, if you look and I have something like negative x minus 1 squared times x minus 4, and this is number 5, you can see that, number 1, the leading coefficient is going to be negative. There's a negative out there. I'm going to have x minus 1 is equal to 0 2 times, so it has a multiplicity of 2. And then I have x minus 4 is equal to 0 1 time. So I solve x is equal to 1, x is equal to 1, and x is equal to 4. So I know that something's going on at 1 and something's going on at 4. Now, looking at my equation, I know, hey, I'm going to have an x squared and I'm going to have an x, and x squared times x is x to the third, so it's odd. So if it was a positive odd, it would start low and end high. But it's a negative odd, so it's going to start high and end low. So in this case, it shows me that I have a multiplicity of 2 at 1. In this case, it's going to bounce off of that one and then go through at x is equal to 4. And it bounces because it has a multiplicity of 2 and at 1, at the point 1, and then it goes through at the point of 4. So hopefully that explains a little bit of the graphing and multiplicity.